Hey, math friends. So our learning target today is I can calculate the volume of a cylinder again, just like we did yesterday, but just kind of in word problem form. So a lot of the same things we did yesterday, just another layer on it, basically. So how do you calculate the volume of a cylinder? Word problems will be kind of given different scenarios. So let's start with what we know about volume. The first one is kind of a review from yesterday. We know that the height is 15, and we know that the radius is 4. The radius is 4. So of course the diameter then would be 4 plus 4, which is 8. The formula for volume says capital B times H. So then we would have pi r squared times H, which would give us 3.14 times the radius squared times the height, which is 15. So this is a review from yesterday that we find the area of the bottom and then we multiply it by the height. So you should be typing that in. Do it, do it, do it, do it. Come on. The area of the bottom multiplied by the height. So the volume of that cylinder, how much it can hold. That is the same question we did in the last lesson. 753.6 feet cubed is the volume of that cylinder. So that's a review of things that we've been doing. So now what happens if we have to undo the volume to get the height? What happens to get the height? Now I'm going to erase all of this, so go ahead, pause the video if you need any of that or rewind it, but I just need space to write. So this is going to be the idea of build house, build fence, clean yard, because what isn't given to us is the height. It's unknown. But we do know volume and we do know diameter. So the diameter is 8, which means that the radius is really 4 plus 4, which is radius of 4, and we know the volume this time is 176. We don't know the height, so that's kind of the given information. So if we use our formula, pi r squared times height, we're going to plug in everything that we have and try to isolate the h this time. So we're going to build our house around the h. So when we do that, we would substitute in for volume of 176 here. We have that pi is 3.14. And we know that the radius is 4, and we're going to square that. The thing that we don't know is the height. So we're going to build our house around it. So this really cool trick that you can do all at once, where you can divide by all of that at once. So I'm going to throw it in my calculator first because it'd be a lot easier to just get the value of that. So 3.14 times 4 squared is the stuff that has to go through division, is 50.24. So all of that equals 50.24. Copy, paste, copy, paste. So the cool part of mathematics is we don't have to do that one by one through division. We can do it all at once. So that equals 1 on that side because that's the equivalent of that. So we go 176 divide by 50.24 and we get, boom, I'm going to round that to the nearest tenth just because it's a little bit, well, I guess I can keep a 0 though. So 3.50 feet is the what? It's the height. It is the height of this cylinder, 3.50 feet. So what we did there is we used build house, build fence, clean yard to isolate the variable h and find the value of h. So that's what I mean by some word problems today. There's going to be some kind of different entry and exit points to the problems. Let's take a look at the next question. How much salsa is missing from the jar? Now we know that this is a volume problem, right? Because it is a three-dimensional cylinder and we're talking about salsa, how much is inside or how much does it hold. So we're talking about the missing section here. And if we know that the entire height is 10, the missing section has a height of 6. So for the missing section of the jar, we have a radius of 5 because that doesn't change. The diameter would be 10 because it's 5 plus 5. Not that we're going to need that, but it's good to think about it. And the height of the missing section of the jar is 6. So how much salsa is that? So volume is equal to pi times radius squared times height. So that's 3.14. The radius of the jar is 5 squared, and the height of the missing salsa is 4. So how much salsa volume is missing? So we multiply that all out, we get 471 centimeters cubed, or cubic centimeters, and that would be this section here, the green section of volume missing from the jar, using the formula that we learned yesterday. All right, let's take a look at the next question. I'm going to actually skip that question. I think I'm going to skip that question. So next question, what is the volume of orange juice that you make? So again, don't look at that arrow there. Look at the entire line as the diameter. So we know the diameter is 3, which means the radius is half of that. That's 1.5 plus 1.5. And we know that the height is 5. So to calculate the volume, it would be pi r squared times height. So we'd have 3.14 times the radius squared times the height. So the volume then would be 3.14 times 3 squared times 5. The area of the bottom, the area of the circle, times the height gives us 141.5 inches cubed is the amount of orange juice that fits in that can. How much volume does the can hold? All right. So let's talk about a couple of these type of questions, just problem solving, thinking about it questions. Which of the following things does not belong? So we're talking about a cylinder, and we're talking about volume. Which of these is not true? This would say that how much does it take to fill the cylinder? Does that have to do with volume? Yes. That one's good. Well, I guess I don't know that yet. I guess I cheated a little bit because I know where this is going. So how much does it take to fill? Okay, volume. What is the capacity of the cylinder? Volume. How much does it take to cover the cylinder? On the outside, surface area. There it is. Because the last one, how much does the cylinder contain? Volume. Volume, volume, volume. How much does it take to fill? What's the capacity? How much does it contain? How much does it hold? All volume questions. What about if we're going to cover it? Like we're going to put a label on it that says peas, or we're going to wrap it? That's a surface area question, which is the next lesson in our class. And the last question of the day. A cylindrical swimming pool has a diameter of 16 feet and a height of 4 feet. What is the volume of the pool? So you have this cylindrical, oh boy, pool. It has a diameter of 16 feet and it has a height of 4 feet. What's the volume of the pool? Easy peasy lemon squeezy. So we have pi r squared times height. So we're going to have 3.14 times the radius. Well, the radius really is 8 plus 8 to get that 16. We square that times the height of 4. So we're going to plug that all in. So we have 3.14 times 8 squared times 4 is 803.84 feet cubed is the amount of water that pool holds. So we're talking capacity. We're talking volume. We're talking how much does it hold. That is the second lesson of volume of cylinders. This was more word problems today. That's really the end of the lesson. I'm not going to really summarize too much because it's that same formula we used the day before. Have a glorious night.